Hi, today's topic is Cholesky method, which is a part of LU decomposition method. This method is also known as square root method. In this method, we have to decompose the given matrix A as L transpose. L is the lower triangular matrix and L transpose is the transpose of the L matrix. In the next step, to follow with the working procedure, LZ equal to B. B is the right hand side matrix, as we all know already, which we learnt in our earlier classes, and Z is the column matrix Z1, Z2, Z3. And the third step we have to perform, L transpose X equal to Z, where X is the matrix of the unknowns X, Y, Z. So initially with A equal to L transpose, we have to evaluate L11, L21, L22, L31, L32, L33, the elements of the lower triangular matrix, and write down the L matrix and find its transpose, and then perform the second and the third steps to evaluate the values of the unknown. So using Cholesky method, we can solve a system of linear equations and find the values of the unknown. Another advantage of this method is that we can find A inverse with Cholesky method. Now let us see a problem. The first problem, solve the system of equations by Cholesky method. x1 plus 2x2 plus 3x3 equal to 5, 2x1 plus 8x2 plus 22x3 equal to 6, 3x1 plus 22x2 plus 82x3 equal to minus 10. This system can be written in the form of Ax equal to B, and thereby we get the coefficient matrix, the A matrix, as 1 matrix 1, 2, 3, 2, 8, 22, 3, 22, 82 into the column matrix X, that is x1, x2, x3 equal to the right hand side values, which forms the column matrix B, 5, 6, minus 10. We need to observe one thing here, that the A matrix is a symmetric matrix. Hence, the solution will also be symmetric in nature when we find A inverse. But now we have to solve the system of linear equations. So we proceed to find the values of the unknowns x1, x2, x3. Now the given matrix is written in the form of A equal to L transpose. Now with this, the A matrix is equal to L matrix L11, 0, 0, L21, L22, 0, L31, L32, L33 into the transpose of this matrix, which is L transpose, L11, L21, L31, 0, L22, L32, 0, 0, L33. And finding the product of these two matrices, we get this 3 by 3 matrix. And on the left hand side also we have a 3 by 3 matrix. Hence, since the order of the matrices on either side are equal, we can equate the corresponding elements on both sides. Thereby we can solve and find the values of the unknowns in the L matrix. So L11 square is equal to 1, corresponding element. Equate the corresponding element. L11, L21 is equal to 2. So with L11 square equal to 1, we get L11 equal to 1. L11, L21 equal to 2. Substitute for L11 and we'll get L21 equal to 2. L11, L31 is equal to 3, the corresponding element. Hence, L31 is equal to 3. L21, L11 is equal to 2. With that, we can find L21 value by substituting L11. So we should observe here that L21, L11 and here L21, L11, these elements are the same. Elements below and above the principal diagonal are the same. That's why we say that the matrix is symmetric. Next, L21 square plus L22 square is equal to 8. So substituting for L21 square and solving, we'll get L22 equal to 2. Next, L21 L31 plus L22 L32 is equal to 22. So substituting for L21 L31 and L22, we can get the value of L32. Finally, L21 square plus L31 square plus L32 square plus L33 square is equal to 82. So substituting for L31, L32, we can evaluate the value of L33. So we have to follow the same procedure that we followed in Kraut's method and Doolittle's method to find the values of the elements of the L matrix. Now having found these values, substitute in the L matrix. So L is equal to L11 0 0, L21 L22 0, L31 L32 L33. So substituting the values that has been found here, we will get the L matrix. And take the transpose of this, that will give us the L transpose matrix. Now having got the L and the L transpose matrix, now we have to go to the next step, that is Lz equal to B. With Lz equal to B, substitute for the L matrix and the Z matrix. So L matrix is here 1 0 0 2 2 0 3 8 3, and the Z matrix into the Z matrix, that is matrix Z1 Z2 Z3 equal to the B matrix. So when we multiply the left hand side matrices, we will get a 1 by 3 matrix. A 3 by 1 matrix, that is a column matrix, 1 column. And similarly on the right hand side also we have a 3 by 1 matrix. Hence, since the order is the same on both sides, we have to equate the corresponding elements, and thereby we can get the values of Z1 equal to 5. Substitute for Z1 here in 2Z1 plus 2Z2 equal to 6, the second row elements. Substituting for Z1, we can evaluate Z2. Having got Z1 and Z2, from the third row we get an equation 3Z1 plus 8Z2 plus 3Z3 equal to minus 10. Substituting for Z1 and Z2, we get the value of Z3. Having got Z1, Z2, Z3, we can write the Z matrix, the column matrix 5 minus 2 minus 3. And we move on to the last step to find X, the unknown, the matrix of unknowns. L transpose X equal to Z. So L transpose matrix is here, X matrix is the matrix of unknowns equal to the Z matrix that has been obtained in the previous step. Multiplying the left hand side matrices, we will get a 3 by 1 matrix, and therefore we have to equate the corresponding elements. So we start equating it from the last row. Since the last row has only one unknown, that is 3x3 equal to minus 3. Therefore x3 is minus 1. Then write the equation from the second row, that will give us 2x2 plus 8x3 equal to minus 2. Substituting for x3, we can evaluate x2. And substitute for x2 and x3 in the first equation formed from the first row, that is x1 plus 2x2 plus 3x3 equal to 5. So substituting for x2 and x3, we can find x1. Hence x1 is equal to 2, x2 is equal to 3, and x3 is equal to minus 1. By solving this way, we can find the values of the unknowns x1, x2, x3 using Cholesky method. To verify if the solution is right, we have to substitute it in any one of the given equations and check for correctness. Thank you.